The broadcast is now starting. All attendees are in listen-only mode.
Good evening and welcome to the RSES Technical Webinar Series for members. I'm Jeannie Birch, RSES Conference Seminar and Webinar Manager. I would like to welcome everyone to tonight's session on proper humidity presented by Marcus G. Matoya, CMS, MS. The RSES webinar series provides RSES members with additional value for their membership dollar. We are now offering an opportunity for those who missed the live webinar to earn the CEH credit by going online to the online store and going to RSES webinars, view the archive webinar, answer the 10-question quiz correctly, and you will receive credit. Typically, these webinars are being held live on the fourth Wednesday of each month. Upcoming topics include on March 22nd, electrical meter usage. On April 3rd, we will be holding a bonus webinar, proper condensing unit selection. And a bonus webinar is going to be presented by a manufacturer. It will be technical in nature, not a sales pitch, but it will give you some great information. And that will be on a Thursday as opposed to our usual Wednesday. And then our regular webinar series on April 23rd will be refrigeration controls. Tonight's presentation is being recorded and will be available online for your viewing convenience in a few days. Marcus's presentation will last approximately 45 minutes, and afterwards there will be question and answer session. Because we've got so many attendees, we're going to ask you to submit questions using GoToWebinar dialog box on the right-hand side of your screen. I'll field the questions and ask them aloud to Marcus. Be sure to participate in the poll questions during the presentation and take a few minutes to answer our brief survey on tonight's session. We want these events to be as useful as possible for you, and the survey is a tool to let us know what you think. Again, thank you very much for joining the webinar tonight. And now I'm going to change over to Marcus. And Marcus, I'm going to let you take it away.
Well, welcome everybody. My name's Marcus Matoya. My nickname is Butch. I got stuck with that many years ago. My company is 777 Education and Consulting here in Lansing, Michigan, where it is pretty close to 10 degrees above zero Fahrenheit. I also am employed by Michigan State University. That's my full-time job, and I teach construction management courses. But I taught for about 30 years in the school system, HVAC courses, and for a wholesaler that's local, and I ran a contracting business for a little over 40 years. So I've been there and done that, but I don't know everything. Still learning like all of you folks are. This presentation is going to cover humidity, and we're going to deal with the United States and Canadian climates only. I know there are people that are international that are joining us this evening, but we're really going to concentrate on the United States and Canadian climates. Some questions might come from other climates, and we will deal with those as we can. Humidity. Humidity is vapor. That's water vapor, and it's present in the air. Types of humidity are percent relative humidity, and that's RH is the abbreviation. That's going to be the basis of today's discussion. There's also absolute and ratio humidity, and a couple of other types that we won't mention. Relative humidity, that's the amount of humidity as a percent in a given air sample, and it's relative to how much humidity the air sample could contain if it were fully saturated. In other words, not able to hold any more humidity. 10% relative humidity means that the air sample, that is 10% relative humidity, has 10% of the moisture that it could hold. 50% simply means that the air is 50% saturated. In other words, it contains 1/2 of the moisture that it could hold. had it been fully saturated. What are the benefits of adding humidity? And that's in the event that relative humidity is too low. Better health. Some of my students at Michigan State University have indicated in this very cold weather that they wake up with nosebleeds. That's one of the side effects of low humidity in a living unit or a working unit. You can also develop coughs. Sometimes lots of things that we don't like and that can harm us propagate or populate themselves very, very quickly and at high levels in low humidity or high humidity as well. Comfort. Comfort is a huge issue. If humidity levels are too low, we can be very uncomfortable and we require a little more heat. So our thermostats would have to be set higher. And we're talking predominantly about winter humidity. Energy savings. If we have to set our thermostat a degree or two warmer than normal in order to offset the effects of low humidity, it's going to cost a little more in energy in order to heat our structures. Preservation. Growing up as a kid, we had terrible trouble with our dining room chairs falling apart, and that was because of low humidity. We had a two-pipe steam system, and humidity levels would get incredibly low in the middle of the winter. Well, what happens when outdoor air leaks into a building during the winter in many of the world's climates? Air leakage from outdoors is also known as infiltration. Unless the grains of moisture, which are drops of moisture, are added to this air, if the grains remain the same, relative humidity will be lowered. And we will explain that in just a second. Lots of people think heating systems dry out the air. Well, typically they do not dry out the air. But it'll be clear in a second why running a furnace in the winter, when you couple that with air infiltration, can actually lower your relative humidity. These are sources, and this comes from the government. This is an Energy Star graphic which shows air leaking into a house as blue arrows, and it shows air leaking out of a house, or any structure really, in red arrows at the top. There are lots of sources of air infiltration into a home or a place of business. This is a good example. We're going to look at 3 examples where we have outdoor air and indoor air at different temperatures. But we've kept the absolute humidity levels constant in each one of the examples. In other words, our outdoor air is 50 degrees dry bulb, and this is all Fahrenheit. 50 degrees Fahrenheit dry bulb is simply a plain old thermometer temperature. There's no humidity taken into account. And we also, for the outside air, have 45.3 degrees Fahrenheit wet bulb. That says percent. Sorry about that. That's a typo I didn't catch. That's 45.3 degrees Fahrenheit wet bulb. Well, that air sample, we've got 37.4 drops of moisture per pound of air. That's 37.4 grains. That then gives me a humidity, relative humidity, of 70%. Well, if I bring that air indoors, in other words, I allow that outside air to leak into my house or into my place of business, and I heat that air to 70 degrees, that 70 degree air would now have a 54.2 degree Fahrenheit wet bulb. And since I didn't change the grains, remember I said if you don't change the absolute humidity, if the drops of moisture or grains of moisture per pound stay the same, then look at our relative humidity, what happened to it on the right side. It started off outdoors at 70% relative humidity. It leaked into the building, was heated up to 70 degrees, and because I heated the air, it can now stand or contain much more moisture. So relatively speaking, the humidity went from 70% relative humidity outdoors. Once I brought it in and I heated it, the relative humidity went down to 34.3%. So the simple process of allowing that outside air at 50 degrees to leak into the building, and now we have to heat it up to 70 degrees, the relative humidity dropped. Not all that significantly, but it dropped by more than half. The next example shows 20-degree dry bulb. Now our outside is colder. We've got 17 degrees wet bulb, and we've got 8.9 grains of moisture per pound. And remember, a grain is roughly equivalent to a drop of moisture. Now my relative humidity is 59% under those changed outdoor conditions. But if I bring that air into the building and I heat that air to 70 degrees Fahrenheit, but I leave the grains unchanged, because simply bringing the moisture into the house is not going to change the grains. By leaving the grains unchanged, I now have 8.2% relative humidity. And that's simply the process of allowing that 20-degree air to come into the structure, and now I heat it up to 70 degrees. And the relative humidity drops because of the heat added to that air. And that is identical to the process that happens in your home or your place of business when 20-degree outside air is allowed to infiltrate to the indoors. So that's the process of how the humidity goes down when we operate our heating systems, because our heating systems are only going to operate when the outside temperature, in this case 20 degrees, is lower than our desired inside temperature. And this is an extreme case, almost what we're dealing with here in Lansing, Michigan today, where my outdoor air temperature is 5 degrees dry bulb, and my wet bulb temperature is 42 degrees Fahrenheit. Again, a typo. Sorry about that. Now my grains are 5.7 for that 5-degree outdoor air, and that gives me a relative humidity of 80%. So it might sound like if I allow that air to come into the structure, which I have to, because air is always going to leak into a building in different or at different rates. By allowing that air to come in, I have to heat it up so that the people will be comfortable. If they have their thermostat set at 70, I'll heat it to 70. Well, if the grains don't change, if the grains stay at 5.7, the humidity is going to go down once I heat that air up from 80% down to just 5.3% relative humidity. Now I'm in a condition where you will have all kinds of problems due to that low humidity level. Well, why is humidity important? It's important for some of the reasons we've mentioned, but one of the main reasons is health. We have several irritants. We have several conditions which you try to avoid as a contractor or a service tech. You don't want bacteria to be able to grow and propagate. Same with viruses, mold, dust mites, dry nasal passages, allergies and asthma, furniture, just like our dining room chairs that used to keep falling apart due to being dried out all the time in the middle of the winter. The building products in your home or place of business made out of wood can also dry out and shrink. And the one that most people identify with low humidity is static electricity. But static electricity is not only a nuisance because you get a shock when you turn on the television. Static electricity can also harm a lot of our electronics today. Cell phones, computers, televisions. The sweet spot for ideal humidity is at 50%. And we're going to talk about under what conditions you can't maintain 50% inside a structure. That's too high. But in a perfect world, we'd be able to maintain 50% every place we live or work, and we would minimize the effects of all of those irritants and problems. You see, there are very few things that happen right in the center. You pretty much eliminate bacteria. You almost eliminate viruses. There's just a little bit of virus production that would happen at 50%. But you eliminate almost all things at the 50% range. The sweet spot, though, is actually a range of 40% up to 60%. That's the ideal humidity range. If I were to maintain even 50% in my own home, it's going to go down to 11 below zero tomorrow, Fahrenheit. If I were to maintain even 50% humidity, 40% or 60%, any place in the ideal range, when I would get up the next day, all of my windows would have a tremendous amount of condensation on them. Because for my window type, that kind of humidity level is too high for that low of an outside temperature. The outside temperature, as it falls, your inside glass temperature also falls. And your glass temperature can eventually get down to the dew point, and it will get down to the dew point, and the glass will begin to sweat if your humidity levels are too high. Humidification climates. There's basically two climates. One in the U.S. is the west and the southeast regions. They may not require any residential humidifier. There are commercial applications where you need humidifiers pretty much regardless in those areas. Also in the southwest, midwest, northern, and mountainous areas of the U.S. and Canada will likely benefit from a humidifier during the fall and winter months. But keep in mind that a lot of new construction, especially new construction that is wood framed, does not require a humidifier, because newer buildings are built so tight, and the amount of moisture produced simply from living or working in the space might produce enough humidity to keep the conditioned space comfortable. And this is simply a map. The source was Honeywell, that shows humidification needs in normal circumstances and humidification not normally needed. And you see the western United States and the southern, southeastern United States. Humidity is not normally needed. Remember, we're still talking about winter. In the summer, we don't normally want to add humidity. The next slide shows a humidification loads determination table that came from AHRI Guideline F. The source is right at the bottom. If we look at a type of construction, either tight, average, or loose, and I have to be the first to tell you this is very subjective, because unless you do a blower door test, you don't know whether you're leaking lots of air into a building, so it's loose construction, or whether you're leaking very little air into a structure, so it's tight, or whether it's an average amount of leakage. So that's pretty subjective. But in the first house my wife and I bought, I was watching a football game one Sunday, and I felt something cold on the back of my neck, and it was actually snow coming in through our old single pane wood frame windows that were not caulked very well. So that was definitely a loose construction home. Well, once you've identified, at least come up with a type of construction, loose, average, or tight, then they recommend that you take the building volume in cubic feet. And in this case, I've taken 16,000 cubic feet as the building size. That would be a 2,000 square foot house with 8-foot ceilings, 1 story. Could be 2 story, but we've got an 8-foot ceiling. you see that the tight constructed home would require 8.5 gallons per day, or 17 gallons per day for average construction type, and a whopping 25.5 gallons for loose construction. It would only make sense that a homeowner that has a loose home, or a business owner that has a loose business that leaks lots of air through infiltration, they would be money ahead to try to seal up a lot of those cracks and gaps to the outside, because that's not only going to reduce their humidity requirement, it will reduce their heat load as well, their heat loss as well. And this document is available at this website. It's a fairly extensive document. This is just one table from that document. Popular humidifier types. There's central humidifiers, ones that are typically put on a heating system, an air handler, or main trunk lines. They make them fan powered, so they have their own fan to circulate air through whatever evaporative media there is. So they have a fan that'll actually blow warm or hot air through a media that has water dripping over it. A bypass humidifier is almost the same as fan powered, but it will use the air handler or furnace fan to actually create the pressure drop that it needs to force air through the media. So there's no external fan required, I should say internal fan required for a bypass humidifier. It just uses your system fan to produce moist air. And steam. Steam has been used for a long time in commercial, but it's finally seeing the light of day in residential applications as well. And lastly, when we had an apartment, we had a portable humidifier. One of the worst things ever invented, in my opinion, unless people really take care of it, because they can really get foul smelling if people don't keep on top of preventing algae and mildew from growing on the inside. But if you don't have a mechanical system with forced air, a portable humidifier may be, not always, but it may be a person's only option to increase the humidity level in their home or place of business. With regard to central humidifiers, one of the things that a person should really think about is, do they want their humidifier to have a pan with a float that actually has a water reservoir, so there's always standing water inside the humidifier, just like with a portable humidifier, because that's going to require lots of maintenance on the part of the homeowner or the maintenance people at the building. So the best situation for a central humidifier is when water is no longer needed to provide humidity to the conditioned space, that you actually have all of the water that's inside the humidifier drain away. So there's no standing water during off cycles. And that drastically reduces maintenance. Psychrometrics. In one of the classes I teach at Michigan State University this semester, I teach psychrometrics. And when this word comes up on the screen, you can almost read the fear in students' eyes. It's a very simple but powerful subject for professional service tax and system designers. It's the study of the thermodynamic properties of moist air. And there's a chart that's been used and is used for this study. And this is the chart. It looks very imposing, but once you know just a few details about the chart, it's very, very simple. And we're going to cover the highlights of the chart. The most commonly measured and referenced values are wet bulb temperature, abbreviation WB, and dry bulb temperature, abbreviated dB. There are a lot of other measures such as sensible heat ratio, relative humidity, dew point, enthalpy, grains of water vapor per pound of dry air. Per pound of dry air is kind of an abstract concept for most of us. Pounds of water vapor per pound of dry air. And a chart, even the chart that you're looking at, has a lot of other features, a lot of other things that you can find out about a given air sample. Well, the thing to remember first about a psychrometric chart is it simply allows you to determine the characteristics of a given air sample. It may be supply air, or it may be return air. Or you can use the chart to actually cover a process where your return air goes into a machine at one temperature and humidity, and it leaves the machine at another temperature and humidity, and you can actually tell what happened to that air. And you can determine the quantities of what happened to that air. If I know nearly any two of those, in fact most of those would fall into this category, you can actually find a point of intersection. And that's all you're trying to do for a given air sample, is determine a point of intersection on that chart. Once you've got a point of intersection, you can determine practically anything you want to know about that sample of air. There are approximately 7,000 drops of water in 1 pound of water. In other words, 7,000 grains equal 1 pound of water. 1 grain is equal to approximately 1 drop of water. Well, the temperatures that you need in order to use the psychrometric chart that are easiest to determine are the dry bulb temperature, because you just need a regular old thermometer, and the wet bulb temperature. The wet bulb temperature is achieved by simply taking the dry bulb thermometer and putting a wet wick over the end of it, and then passing air across that wick in order to determine the wet bulb. So you literally could use the same thermometer to get both, but you can't get both simultaneously. It's going to take a while before you can go from dry bulb to wet bulb if you're using the same thermometer. But you literally could. This is a good look at a dry bulb thermometer. You can see down here where the sensing portion of it is, there's nothing on it. It's just plain glass. This particular one has mercury in it. A wet bulb thermometer, as I said, is nothing but a dry bulb thermometer. Yes.
Are we going to do the poll question?
Oh, yes. Go right ahead.
Okay, we're going to launch the first poll question. We'll give you a few minutes to answer. Okay, we're going to close the poll, and we're going to share the results. The results were 4% chose A, and 96% chose the correct answer B, which is false. And we will close the poll and go back to Marcus for
So you can see that the dry bulb thermometer just has a water-wetted cloth wick on it. If you wanted to be really precise, you would only use distilled water when you're wetting the wick. And a lot of people have asked, where do I get a wick like that? Practically any sling psychrometer, and I'm going to cover what that is, the wicks are available separately from that manufacturer, from that vendor. You can also, if you have older athletic shoelaces, those older athletic shoelaces are hollow, and those make excellent wicks. In fact, the wick material that you buy from a manufacturer looks very much like an athletic shoelace, but it has to be hollow so it'll slip over a regular dry bulb thermometer. And we'll also get into electronic devices where you don't have to actually wet anything. Hygrometers are either analog, where you've got a needle that indicates the relative humidity percent, or digital. And there are literally hundreds of types of digital and analog hygrometers for measuring relative humidity. You could use these instead of a sling psychrometer. So they're much easier to use and much more foolproof, except they have a tendency to lose calibration, where when you're dealing with wet and dry bulb thermometers, there's no calibration requirements. They're accurate until they either get broken or they get overheated, where you may actually lose some of the liquid that's inside. The sling psychrometer is another type of hygrometer, and it uses two thermometers, the wet and the dry bulb sensing element. The nice thing about a sling psychrometer is there's no calibration, no electronics to worry about getting out of calibration. And this is a look at a typical sling psychrometer. It happens to be the one that I carry in my briefcase.
Okay. We have another poll question.
Okay.
Okay, and we're going to close the poll now and share the results. And 8% said true, and 92% had the correct answer of false. And we'll go back to you, Marcus.
Okay, thank you, Jeannie. And this is a little closer up view of the sling psychrometer, both the wet bulb and the dry bulb. So it's obvious that you can actually get both readings simultaneously without having to use the dry bulb and then put the wick on the wet bulb, wet it, and then actually spin it around. Many sling psychrometers actually have a built-in calculator, so once you get the wet bulb and dry bulb, kind of like a slide rule, you can line up the two temperatures on this scale, and it will actually tell you what the percent relative humidity is. So it's a pretty trouble-free instrument for measuring relative humidity. Fog occurs when the wet bulb equals the dry bulb. And under those conditions, the air is fully saturated. It cannot hold any more moisture. So therefore, fog is produced. And in this case, we've got a 70-degree dry bulb and wet bulb. So under that condition, our relative humidity is 100%. It's obvious that if this temperature and this temperature with air passing across it, in other words, the dry bulb and the wet bulb are the same, we're not able to evaporate any moisture off of our wick. So by not being able to evaporate any moisture off the wick, that tells us that our air is completely saturated. And this shows a young lady actually doing a measurement with a sling psychrometer. In this case, she got a dry bulb of 70 degrees Fahrenheit, and she got a wet bulb of 55 degrees Fahrenheit. Proper practice requires you to rotate that at a speed of between 120 and 180 RPM. And you don't simply do this once for a couple of seconds and read your figures. You do it multiple times until two subsequent readings are the same. That tells you you've stopped evaporating moisture off of that wet bulb and that your dry bulb is also stabilized. Some folks think, well, when you're spinning this around between 120 and 180 RPM, that the dry bulb temperature is going to also be affected. It is not. If it's 80 degrees outside in your city, 80 degrees dry bulb, you're riding down the expressway at 70 miles an hour, and you stick a dry bulb thermometer out the window, the dry bulb thermometer will not be affected. It will still read 80 degrees. But put a wick on that, and your actual wet bulb will change unless you have 100% relative humidity. This slide shows the key components that we're going to talk about today. Green is the wet bulb. That's right there. Red is the dry bulb. And blue is the relative humidity. Blue is a curve, not a straight line. Well, let's use the data gathered by that young lady. Dry bulb 70, wet bulb 55, both degrees Fahrenheit. The dry bulb temperature is indicated on, if you remember back to elementary school, it's on the x-axis. So these are dry bulb numbers on the bottom. And this indicates that the x-axis is dry bulb. So 70 degrees dry bulb is what the young lady determined. At the bottom of the 70 red line is 0% relative humidity. At the top of the red line, where it intersects with the curve, it's called the saturation curve, that's 100% relative humidity. So that line extends from at the bottom 0% relative humidity to 100% at the top. And we know that the relative humidity is going to be someplace between 0 and 100%. We just don't know where it falls. You see the wet bulb temperature, and there's several temperatures indicated by the curve. But wet bulb is what we want to deal with in this brief presentation. The wet bulb is 55 degrees Fahrenheit, so it's going to be a blue line to keep the color code going. And the wet bulb goes from 55 on the curve, that's the saturation curve, 55 degrees wet bulb, and it follows the diagonal line down to the x-axis. Well, what I've just determined, folks, is the point of intersection. The point of intersection is the only reason that I gathered those two temperatures. That point of intersection tells me everything I need to know about that air sample. And we could see she was standing outside. So that is the intersection point on my psychrometric chart for that outdoor air sample. It's 70 degrees dry bulb, 55 degrees wet bulb, both degrees Fahrenheit. Well, that's the relative humidity. The relative humidity, which is circled in green, or is ellipsed in green, that's 10%. Pretty small, but it's 10%. Each successive curve, as you go up to successive curves, you can see the percentage increases. Until I get up here to this one, which is 90%, and you can probably guess that this curve is the 100% relative humidity. So that's what's called the saturation curve. So all I need to do now is estimate where my point of intersection is between two known relative humidity curves. And you can see that it's between 30% and 40%. So I'm going to estimate, because it's closer to 40%, that my relative humidity is, let's just say, 38%. Now you can see you can't get really precise with the psychrometric chart, but you can get very close to the actual values for your air sample. We also have grains of moisture per pound. Remember, that's approximately 1 drop of moisture equals 1 grain. Well, you find out that value by taking your point of intersection and drawing a perfectly horizontal line until it intersects the grains of moisture per pound of dry air. And you can see there we're just over 40 grains of moisture per pound. And I've estimated it at about 41. You'll all be glad to know that I'm going to show you some free software that will not require you to be able to use the psychrometric chart. But I think it's valuable to know where that information can be found if you don't have the software available to you. Outdoor temperature.
We have another poll question.
All righty.
Okay, we're going to close the poll and share the results. 4% said true and 96% had the correct answer of false. You must be doing a great job, Marcus.
No, I just have smart students tonight.
All right. Back to you, Marcus.
The next slide is a table that you find in lots of manufacturers' operating instructions for humidifiers. It simply tries to give the owner, the homeowner, or building owner, an idea that as the outside temperature goes down on the left side, the left column, that the recommended relative humidity goes down as well. And that's because as the outside temperature goes down, your building materials, such as the temperature inside of your walls, your glass temperature, all of those things that are exposed to those cold outside temperatures have their temperature go down. So as the temperature of glass, for instance, goes down, you need to have a lower relative humidity so you don't condense moisture on those windows and condense moisture within your walls or cold ceilings. And that recommendation is going to depend totally on the type of windows that you have in the building, and also the type of vapor barrier or vapor retarder that you have in your walls and cold ceiling. This is a really good chart. First time I've ever seen something like this was when I put this webinar together for RSES. But this shows condensation and where it forms at different relative humidities at different outdoor temperatures for different window types. I've taken an example where the outside air temperature is 20 degrees. And then I looked at single glazed, which is just single glass windows. At 20 degrees, condensation would start to form at just over 20% relative humidity, maybe 22 or 23%. But if I was to change out those single glazed windows and go to double glazed low E windows that are argon gas filled, I could have a much higher humidity level at the same outside temperature without forming condensation on those better windows. And the next slide just gives you a little more detail, and I'll let you guys read that at your leisure when you go through this later to review. Humidity that's required, you should follow your humidifier manufacturer's recommendations for the building type and use. You're going to have house requirements, print shop requirements, data processing, offices, and the list goes on and on. A print shop may require a lot higher humidity than offices. Low humidity symptoms, static electricity shocks, furniture destruction, dry building materials, health problems, which we've discussed. High humidity symptoms could be moisture on windows, and the moisture on windows could be because the humidistat is set too high, or you're generating lots of moisture inside through normal living or working activities. You can also damage building walls, ceilings, and floors. You can get rot, mold growth, All sorts of problems can come from high humidity. Humidifiers are not recommended for use in buildings without the proper vapor barriers or retarders because of potential damage of moisture buildup. I mentioned it's going to get below 0 tomorrow night. You can be very sure if I did not have a good vapor retarder that moisture from my house would go into my walls and actually condense when it got near the outside of my walls. And if that happens frequently, it's going to rot out your studs, rot out your plates. And the best way, in my opinion, to find out whether a given house or place of business has proper vapor retarders is to hire a building contractor, one that's reputable, that knows what to look for. Building science is changing almost every day. What I learned in high school about residential construction is totally different now. They found out what we used to do actually can be detrimental to a building. And this is an outstanding website, buildingscience.com, because as I said, things are changing almost every day. But all of their information is free when you look at the information that's available. Naturally, they have a bookstore and they have seminars where there may be a cost involved. If I was to click on the information tab on the previous slide, it would take me to this page, and I could find a whole host of documents. Some I may have an interest in, some I may not. But the ones you have an interest in, you can download them and read them at your leisure. And if you don't see anything here, and you can actually scroll down and see more, rather than go through a bunch of documents, if you're only interested in vapor retarders or vapor barriers, you can just enter that in the search criteria. And it'll take you to the articles that are available with those search terms. Well, this is the software that I said you guys could get for free, and this is the link, www.handsdownsoftware.com. And I've used the free version for probably 8 or 9 years. Before, about 5 years ago, I actually purchased the professional version because it has a lot more features. But for service work, for installers, for residential and light commercial system designers, the free version will do everything you need to do with Psychrometrics.
Okay, we have our final poll question now.
Okay.
Okay, we're going to close the poll and share the results. And on this one, 97% said A, which is true, and the correct answer, and only 3% said B, false. So then once again, they were on top of it.
Very good. Well, this shows the home page for Hands Down Software, and I have no affiliation with them. I've never talked to the gentleman that started this site, but he's done a great job, and the cost is exactly right. It's free, unless you want the professional version. There's the website URL, and if you click on downloads, that gets you to this page. And if you're a carrier dealer, like I used to be, you'd simply click on download now for the carrier. They don't have a lot of free company-sponsored downloads available, but you can see here they've got Carrier, they've got Train, they've got York, they've got Heatcraft. I don't remember how many they've got, but it's not a complete list. If you get the professional version, you can actually get your company name shown right on the software. But that is the download page. Additional information is available at RSES, both the Journal and SAMS for members. And I listed a couple of manufacturers. The first one is Research Products, that most of you guys know as April Air. The next two large humidifier manufacturers are Scuttle and Honeywell, but there are hundreds of others. And lastly, for research information, design information, ASHRAE and AHRI are two great sources for additional information on not only humidification, but lots of other topics as well. And lastly, building science, which we just went through a second ago. I'm ready to open it up for questions.
All right. Let me see here. Okay. Is there a recommended humidity level for different application like library, post office, indoor spa, pool, humidor for cigar?
Yes, ASHRAE has all types of building uses and occupancies, and they have recommended humidity levels for almost anything you can think of.
Okay. With a sling psychrometer, do we need to worry about freezing the tool in the winter when we have them in the vans?
No. In fact, the first mistake I made when I bought my first one, when I was about 19 or 20, I left the water inside of it, put it on the dash of my truck, and it froze and broke the thermometer. So don't leave water inside of it in cold weather. In fact, don't leave water inside of it in warm weather, because you can get mold and mildew growing on that wick. So what I always did was, after I had that mistake the first time, was I actually would take the wick out between uses so that it could completely dry and I would not damage my sling psychrometer.
Okay. What is a slide rule?
A slide rule is what us old-timers used to use to perform mathematical calculations before they came out with calculators and computers. But a slide rule is a device that is old-school calculations. And one is built into that sling psychrometer that I showed you, but it's only designed to give you relative humidity, if you know the dry bulb and the wet bulb.
Okay. What are your recommendations for data centers?
That is computer specific. Whatever hardware they've got in the computer room, and we used to do a lot of work for the state of Michigan and their data centers. Some data centers required 55% relative humidity year-round. Others required just a little over 60%, and still others where you had high-speed printers that were operating, they were typically in the 50% range. But you should talk with the data center manager and actually ask to see the recommended environment for his or her machines so that you can stay within the range.
Okay, we have kind of a long one here. We are in the Northeast, where it's very common to have central air conditioning systems in unconditioned attic spaces. As more and more houses become air sealed, we are finding mold growth and water buildup in ductwork and inside air handlers. Warm, moist air from the home travels through the return and through the AH and ductwork in the attic. It condenses and literally rains inside. We visited these systems in the summer, and their air conditioning coils are completely engulfed in mold. I saw the chart that recommends certain relative humidity levels at certain OD temperatures, but in our region, even those are turning out to be too high to avoid condensation mold growth. what do you suggest as a solution to the problem? The lighter these homes are, the tighter these homes are becoming, the more we see the problem. It's a tough sell to the customer to tell them to keep their relative humidity at 20% in the wintertime when the American Lung Association is saying that healthy levels are between 40 and 50%.
Yeah, the problem, just based on the question, sounds like the duct system and the air handler and everything in the air handler are probably below the dew point, probably for quite a bit of the year. And when that temperature is below the dew point, just like you take a can of Coca-Cola out of the refrigerator, and if your humidity level inside your house is too high, then you'll actually get condensation on that can of Coca-Cola. So the first thing I would look at is trying to lower the thermal conductivity of that duct system by insulating it. I've had plenty of jobs that I've done in an attic where I've actually had the insulating contractor insulate over top of my insulated ductwork to try to maximize the temperature of that ductwork, both well, in the winter to maximize the temperature so you didn't get condensation inside of it. That seems to be where we're talking about, winter operation. So increase the temperature of that duct and try to keep air from being able to leak inside that duct.
Okay. How long do you spin the psychrometer before it starts drying out?
You should totally saturate that wick. And that wick is long enough that only probably the top 3/4 of an inch is actually on the wet bulb thermometer. And down inside of that sling psychrometer, there's probably a 1/2 foot of wick material. Totally saturate that, and you could spin it probably for over an hour, and it wouldn't totally dry out. As long as you were working with a totally saturated wick, it was pretty long.
Okay. What relative humidity would be recommended for a 100-degree Fahrenheit day?
So we're talking air conditioning, I would assume.
It didn't indicate.
It depends on the design for your area. Here in the Midwest, we design for 55% relative humidity during the cooling season. And that would be if it was 100 degrees outside. That's what we would try to maintain.
What was the web page again for the psychrometric chart?
Can they still see my screen?
Yes, they can.
Okay. Right there.
Thank you. Okay. Digital WB meters, wet bulb meters, better than a sling? It sounds like that's a question.
No. No. And that's because of the calibration issue that you can have. I know in a service van, if that's, the application, a service technician, you go over railroad tracks, that thing is going to bang around in the back of your truck, and they just don't hold their calibration typically. It's kind of like using a manometer to check gas pressure, one that's electronic versus one that actually has you put water in it. There's no calibration issues if you simply put water in a water manometer. And a sling psychrometer is very much like a water manometer versus an electronic device to do the same thing. Yes, I do have electronic wet bulb meters, but periodically I check them with my sling psychrometer to make sure they're still accurate. And if they're not, I send them in to be recalibrated.
Okay. Do you know if there are free apps for smartphones on the charts?
I can't imagine that they don't have them available, but I have not personally had an occasion to try to search one out. And it's because I've always got my laptop with me, and I've got the pro version of it on my laptop. It's just much easier to use. But if I was still in a service van, I would check either on Apple's or Google's site to see if there's any software available. But I got to imagine somebody's produced that for a smartphone.
Okay. Which is more accurate, a sling or a digital?
Sling is more accurate. However, you can't get the number of decimal points. My wet bulb electronic will actually read out to 1/100th of a degree, and you can't get that accurate with a sling psychrometer. But as I mentioned, my digital hygrometer, I check that periodically. In fact, a year and a half ago, I found that it was reading off by about 15%. So I sent it back to the company, had it recalibrated, and now it's accurate again.
Okay. Can you mount a humidifier on the back of an A coil where the fins are not exposed?
That is a dead airspace. And I can't imagine you would get good airflow through the humidifier. So my gut reaction would be no. But I would highly recommend that a person send a quick note, quick email, with a couple of digital pictures if they have them available to whoever's manufacturer or to whoever their humidifier manufacturer is, and ask them, is this a good installation of your humidifier?
Okay. Where is a good place on a residential unit to take dry and wet bulb temperatures?
If you're concerned with return air temperature, which is normally what you want to measure in the winter if you want the home relative humidity, the best place, in my opinion, is in the blower compartment, because that's where you've got the actual air coming from all over the house. You're going to have some basement air if it's a basement application. You're going to have some outdoor air. But if your main concern is to see whether or not the humidistat is accurate up in the living room or the hallway or the entry to an office building, then you'd want to take your reading right at the humidistat, and then you can check the accuracy of the humidistat.
Okay. Should an evaporative humidifier not work better with a new furnace than an old one, considering that the temperature rise between low fire and high fire are approximately the same?
Well, what produces the humidity is the temperature difference. Or in the case of a fan-powered humidifier, simply the temperature on the supply side. Did he say whether it's a bypass or a fan-powered?
No, I'm reading the questions exactly as they're written.
Oh, okay. Okay. Well, yeah, the hotter the air is that goes through that evaporative pad, the more moisture you're going to produce.
Okay. What resource or resources do you recommend if anyone wants to learn more about the benefits of air sealing buildings to address from a source control strategy?
The best source, which is, I hope, impartial, is EnergyStar.gov. In order for a builder to have his house rated as an Energy Star home, there is a pretty extensive sealing requirement that a HERS rater typically would go through in order to verify that the building meets Energy Star requirements from a infiltration standpoint. And EnergyStar.gov is the website.
Okay. Our engineer is controlling a data room at 54% dew point and 74 degrees with 5 chill water systems, 45-degree chill water. Should we go back to relative humidity?
Read that to me again. I think I missed something.
Okay. Our engineer is controlling a data room at 54% dew point and 74 degrees with 5 chill water systems.
Dew point would be a temperature, not a percent.
Okay. 45-degree chill water, and then should we go back to relative humidity? Maybe
Well,
he meant to put degree.
Yeah, I would have to actually use the software to try to find an answer to his question. But every computer room I've dealt with, we've always used relative humidity as our determining factor. And dew point is a function of relative humidity and dry bulb temperature. And with the software, he can very quickly figure out that at a certain temperature, would you say 70-some degrees?
74.
Dry bulb, 74, and a dew point of 50, what was that?
54.
You can just enter those two values, and that'll tell you what the relative humidity is under those conditions, if you're able to achieve those two conditions in the data center. But I know if I try to switch off from this webinar to the software, something's going to screw up and I'll lose you forever.
Let's see. I think I need to spin the sling for 2 full minutes before reading the DBT and the WBT. Is that correct?
Well, in class just about a week ago, I showed the students how to use a sling psychrometer to deal with complaints on mold in a building, because that's what our unit was talking about. And in the classroom, it took me less than a minute to get 3 readings from my sling psychrometer, and the last 2 were the same. So that told me I was done spinning it. I've had other times when I was teaching for a wholesaler here in Michigan where it was probably 6 or 7 minutes before I got 2 successive readings that were the same, that indicated I was done and I could take my readings down. So it just depends. And I think it depends more on the amount of humidity in the air than it does anything else as to how long it's going to take.
Okay. There's a couple of people who have put in that there's an app called AIR, A-I-R, Lite, L-I-T-E, for your Android phone for psychrometric calcs that works well.
Well, whoever sent you that, thank you.
Yeah, there are a couple people put that in there.
Yeah, yeah.
I have seen 2 humidifiers installed on the same duct in a bank application. Can they do that? I think they want more humidity.
Oh, sure. Sure. In most cases, you won't get double the humidity, but you'll get nearly double the humidity by having 2 of them, assuming they're the same size. But yeah, you can do that.
Okay.
If you need 30 gallons of moisture per day, and you don't have a humidifier available to give you that much, you can put 2 of them on. Another thing that people can do, and most people don't think of it, is you can use hot water as your water source instead of just cold water for a water source. In fact, some manufacturers recommend feeding your humidifier with hot water instead of cold water.
Okay.
That really increases the capacity.
Okay. Is it good to have a humidistat on the return duct?
Yes and no. And that sounds like a cop-out. Customers, once they get up in age, do not like to have to go into the basement to fiddle with their humidistat, assuming that's where the return air duct is. They much prefer to have it right on the wall. Because you can see as the temperature outside goes up and down, you really recommended, or they recommend that you turn your humidity control system, your humidistat, either up or down to match the changing outside condition. And manufacturers actually make humidistats now that have an outdoor sensor so that it will automatically readjust when the outside temperature changes, so the customer doesn't have to fool with it. But I think technically is where that question was coming from. Yes, you can put it on the return air duct, and it should work just fine, assuming you don't have a drastically different humidity reading in your return air duct than you have up in the living space, which you're most concerned with.
To remove humidity, do you recommend heat wheels or heat pipes?
In the winter, to remove humidity, ventilation is the best way to remove humidity. And the last few custom homes we did, they did not need a humidifier. And one guy is a friend of mine, and he's been in that house for 8 years, and he's never needed a humidifier. His humidity stays between about 35 and 45% in the winter. And in the summer, it goes up to around 52 to 55%. But if you're asking about winter operation and how you can remove excessive humidity, maybe to prevent mold growth, ventilation is the key. I always recommend going with the least expensive way to solve a problem when it's available.
Okay. Do you recommend supply air or return air mounting for bypass type, also hot or cold water supply?
Depends on what the manufacturer recommends. I have installed, I bet you, 50% of my bypass humidifiers on the return and the others on the supply. Because back in those days, Aprilaire did not have a preference. They said as long as you've got a pressure difference between the inlet and the outlet of it, that's all you require. And I had no problem with any of them on the return side. But I would follow manufacturer's directions. And again, that sounds like a cop-out, but they've tested their product and they know which way it should be installed. Whether you use hot water or cold water, hot water maximizes your performance, but it can actually be a negative with regard to energy consumption. Because if you've got a 95% efficient furnace and you're using some of the heat from that furnace to actually help you evaporate moisture, and you're using cold water, then you have no water heating cost. But if you're using hot water, then you're not getting the real benefit out of that 95% efficient furnace from an energy standpoint, because your water heater is not going to be that efficient. So your water heater is going to run more, and you're going to have slightly higher energy costs because of it. But as we're talking, my humidifier is installed on my hot water line. And it's only because I get enough capacity when it's on hot water. And I'm just a little short on capacity when it's hooked up to cold water.
Okay. Are steam humidifiers good?
In the old days, definitely no. Because the minerals that would be left over after the steam evaporated would put a white powder all over the inside of your duct system and all over the inside of the conditioned space. But I've read but I've had no experience with steam humidifiers in recent years, but I've read that they've got that problem solved.
Okay. In a data center, which is better, a canister type or an ultraviolet type?
Ultraviolet are the ones that I preferred in the computer rooms that we dealt with.
Okay, well, I think we've come to the end of our questions. If anybody that's still on has questions out there that weren't answered and that they would still like an answer to, please email your questions to me at jbirch, B-I-R-C-H, at rses.org, and I will get them to Marcus for his response. And thank you all so very much for attending.
Jeannie, can I interrupt for just a second?
Absolutely.
If the gentleman is still listening, if he would send you a request who had that mold growing in an air handler and duct system in an attic.
Sure.
And if he could send me a couple of pictures, I would be happy to investigate that further. Because I am right now in the middle of taking the latest building science course from a PhD chemist from Dow Chemical. And I will bounce that off of him, plus I will use that information to actually do more research for him. And I'll do that for free. There's no charge.
I actually think that might have been a young lady who sent that.
Okay.
So that would be great. If Carissa, if you're still out there with us, if you can send that to Marcus, that would be wonderful.
Excellent.
Okay.
Well, I thank everybody for their time and their attention.
Absolutely. Thank you so much. We're closing the webinar now.